All right, good afternoon, and thank you for hanging out to the last session of the day. And we're going to be talking about selecting the best data transformation strategy. Now, I know where you work. It really doesn't matter which one that I say best. I mean, let's face it, some point in time you get stuck doing what's there. So if you do get stuck doing one of the ones that I don't think is the best, I'll let you know what you can probably do to improve the situation and the architecture that you had nothing to do with. It's already been selected, because that's the way the real world works. As you might have guessed from my accent, I'm not from here. My name is Ginger Grant. I am a data platform MVP from Arizona, so I am freezing because it's 43 months out of the year there, and that's Celsius. I do know how to translate. I wrote a book last year on cognitive services, and in addition to talking to you guys, I also do data consultancy, and I am a Microsoft certified trainer. So let's talk about data transformation goals, because we know that people have some ideas as to what it needs to do for it to be a good strategy. So what I'm going to be talking about today is exclusive to cloud-based solutions. If you're talking on-prem, I don't have anything for you today. And what we want to do is we want to create a dimensional model. And the reason why is what we're going to probably do with the data that we are gathering is we're going to be putting it into some kind of report. Because let's face it, your data doesn't count unless somebody can do a chart off of it somewhere, or put it in Excel, the largest single data store in the world. And so if we have it formatted in a dimensional model, that makes doing that kind of analysis easier. Probably we want to think about doing ad hoc querying too. Because in addition to just doing like the canned reports the CEO says that we have to have, there's probably somebody who's going to do some one-off weird stuff that we haven't thought about yet. Maybe they're doing some wacky report that is going to be really intense that they need for 4 days. Or maybe we want to make some of the data available for data science, which may or may not use all of the transformations that we did to put it in dimensional model. So I want to kind of think about how we can support things other than reporting, because they come up too. And we got to assume that our data is coming from different places. Our data is going to be coming from maybe an on-prem solution, maybe Salesforce, maybe some random spreadsheet that the marketing department put together. And we need to put all of this together somehow and figure that one out. We're going to need to refresh the data, because it's going to need to be refreshed periodically. When? Well, that just depends on when your data changes. And we also want to make sure that we're looking at doing CI/CD, continuous integration, continuous deployment, so that we're creating code that's reproducible, doesn't have a lot of errors, and that if it does, we can go back. So we got to think about non-happy path when we are selecting what a good data transformation is. So think about it when we're doing our design decisions. Of course, some other things are going to come up. How important is that ad hoc querying to you, and how fast does it have to be? If it doesn't happen that often, then you can get away with a non-database solution. So again, that depends. I mean, how often do you have to support ad hoc querying? Can ad hoc querying in your world mean somebody can put together a Power BI model on their own? Some people count that as ad hoc querying. Some people say, no, I got to do it in SQL. So know your environment to know what ad hoc queries are going to be required. And then, of course, skill base. I have a client right now, and the reason that they're working with me is because they want to do things that are really complex. They'd like to get into Python, but nobody has any idea how to make it work. They think Spark is cool. They think Spark is awesome. They'd really like to get there, and they haven't a clue. So think about if you're saying, oh, no, everybody should write everything in Spark. We should do all the ETL that way. Ditch all of that ADF you got going on. Is that a feasible option given your environment? So you got to think about the way that the world works now and how you can get to where you want to go. And then, hey, Azure spend, because that matters. And if I come up with a Power BI solution that's low code, but it involves you spending, I don't know what the pound equivalent off the top of my head is, but $5,000 a month US for Power BI Premium to support the features and functionalities you need, some people are like, yeah, that's a hard no. We're not going to do that. So all of these things matter. when you're determining, hey, what am I going to do? Because I will say that what I have noticed is that the lower code options cost you more in Azure. So you're paying for it one way or the other. You're paying for it in how long it takes you to figure out how to write it versus how much you pay Microsoft who did the writing for you. But you're going to pay one way or the other. And decide in your organization what you're willing to do. Because that's a trade-off that you're going to have to make. So let's talk about reality, because I'm sure that most people in here have done some kind of data transformation. Some people can make a freaking mountain out of a molehill. Some of this stuff is just unbelievably complex for making a date table. I have a client that did that. I could not believe it. This is for a date table? Oh my goodness. They did this crazy stuff in ADF to make that happen. Merging and joining can be very complex and hard to troubleshoot. But you need to assume that sometime this is going to break. And this is always a situation where you hate the guy who just quit, because you're the fool who's got to go in and figure out what the heck that was done in the code. And when people have a lot of different ways that they can do something, people tend to employ them. Well, what might make perfectly sense, for me, may make no sense for anybody else. So you really have to consider that other people have to be able to understand, read, and follow your code. It can't just make sense for you. And that means, scary, you're going to have to talk to people that you work with and come up with some kind of standards and follow them so it's not, oh, that's Ginger code. Oh, that's Jamie code. You need to have a more uniform way of doing it so that anybody can troubleshoot it because you're following similar design patterns. So looking at other people's code is going to matter for this in this reality. So these are the options that we're going to review. We're going to be doing whether or not you can do everything in Power BI. I was at a conference in December, and someone's like, well, we just do it in Power BI. And I said, just curious, does anybody in your organization have any kind of ETL background? No, we're all business analysts. Okay. I get why you're doing it that way, because that's what you know. So can you make a Power Data modeling, environment successful? Yes. Is it the best? Well, I'll go through some things and I'll let you decide, but I will just, cover that by saying no and get into the reasons why. Azure Synapse Integration and Azure Data Factory. That's the same code base. So I'm not going to make a lame distinction whether or not you wrote it all in Azure Data Factory or you wrote it all in Azure Synapse Integration, because they both have this. If you go look on Microsoft's webpage and you see, how does this feature in Azure Data Factory work? At the top it says yes, and it also works in Azure Synapse Integration. So same code base. That does some different things, but in the main, when I'm talking in that area, I'm going to talk about both of them. Can you make that work? Yes, and it, in great part, depends on how you write it. And there's money to be made in doing it badly. I'm a consultant, and one of the places that I worked, and I did not have anything to do with it. I'm just going to say this right now. The design of how they wrote all of they used Synapse Integration just like they do Data Factory. And everything they did was data flows. And they got a 1-year contract to continue maintaining and supporting it because nobody else could understand what the heck they did. So, there's that aspect of it. And then there's going into PySpark. And a lot of the reasons that people don't do this is because, frankly, they've never done it before and they don't know how to make it work. So that's a reason for not doing it. You don't know how to make it work. And you want to support it ongoing, and you're not sure how to do that. So, and Spark is like anything else. You can write bad code. So and if everybody's starting out on learning more about Python, what you really want to do is look at implementing design standards that mean that you're not taking a mess from, say, SSIS and moving it to a mess in Spark. Because, hey, you can write bad code wherever you like. But looking at how to write good code to make this a very viable option. And then basically looking at how you can do a kind of a combo. Integrate Spark with a integration pipeline. Because what's the old saying, if I have a hammer, everything looks like a nail? pick the best tool for the job. And the best tool is not only which does it faster, but which you're better able to support in your environment, giving the skill level of the people that are working. And then other combinations as well, because unfortunately, I have 50 minutes, and so I can't list everything, but I can kind of throw some things at the end that I think are still really viable solutions, but I'm not gonna have a tough time to talk about, which is Databricks, which is, also, I'm including that in PySpark. You could choose to do it that way as well. All right, Power BI use cases. So is it really easy to create a data model in Power BI? Absolutely. And because of looking at the way that Microsoft has changed the way that the code works, you can now use very large data models, which you couldn't do in the past. So you're not limited to 10 gig. It's very easy to create and modify. People will probably understand how to use it, and you can also use it to implement data security. So, and also, let's face it, most people want to do data integration so that they can create Power BI reports. Well, you're practically there when you've done that with your data model. But let's look at some issues with why that's probably not the best solution. And one of them is the refresh options. They're limited unless you use something else with it, because you're stuck with that every half an hour if you use just the standard Power BI service. And it's not, and so it's not smart. It's just going to blindly kick off and refresh data. You are limited on your ad hoc querying. So if you consider ad hoc querying, I can play around a Power BI model and that's ad hoc querying for you, hey, then great. If someone says, that's not what I mean when I say that I want to ad hoc query the data, and I kind of agree with that, then there you are. And the biggest thing, though, is there's really no traceability in source context, because a PBIX file is a PBIX file. If I change that PBIX file, I changed that PBIX file. What did I do? Did I add a visual? Did I change a name? Did I change the logic that I'm using in Power Query? Who knows? And one thing that, you'd have no idea if somebody checked it in and checked it out, what happened? What did they do? You don't know. And you don't know why, because there's really no way of doing it. And yes, you can integrate it with source control, but we know if you've used Power BI, that's kind of a loose source control. But it's just not possible to know anything because there's no really way of documenting it. And everything is all mushed together. So you don't know what somebody did. So all of a sudden something stops working. It's kind of hard to, you can roll back if you've got the previous one, but what's all in there? You can't really tell. So and basically the other thing that really, with this scenario, you're basically requiring premium. So, because to do continuous integration and deployment, you're probably going to want to implement development pipelines in Power BI, which is a premium feature, which means that your workspace has to be premium capacity or you can't do it. So, when you are considering whether or not to make your Power BI data model, and you're like, yeah, but it's so easy, and then we can get up and running faster, think about how you're going to handle these conditions. Do they matter in your organization? It's like, screw it. We just get the reports out. We do not give a crap. Technical debt. How are you going to choose to spend it? So this will work. But what if you're doing this anyway, because that's what the guy before you started, so you have to finish it. What can you do to make this the best situation that you possibly can, given that you're doing all of your data modeling in Power BI? Well, one thing you can do is use data flows. And the reason why data flows can be important is because you're separating out the tasks. So you're making it not all one giant PBIX file, but you can make a data flow that connects to a single source and bring them together. Because let's face it, and this gets into linking, which is a premium feature, which I pretty much said that you're into if you're doing Power BI data modeling anyway. So you can also, if you want to make much smarter refreshes, you can use logic apps. And if you use logic apps, then you can logically start your data refresh when it makes sense. Like when a file is ready, or when the database is done backing up. not just we're doing it because it's 8 o'clock now. So you can make it smarter if you choose to use logic apps with your refresh. Try to get people to comment the source. It's the only thing you have to know whether or not somebody's done something. So it's the only thing you can do. And one thing also that I think is going to be a good feature in the future is the use of data marts. Because what data marts do is they make a SQL Server instance, or Azure SQL instance, of your data model when you create a data mart. This is in preview now, and while I think that this is going to be a really good feature in the future, right now it only does direct query, and direct query is unbelievably slow. So I don't think it's something that you might want to consider going forward. So for those of you, I know that, it's funny, I was talking to this friend of mine, and I'm like, seriously, why would we want to do a data flow anyway? Because it's Power Query in the cloud, who cares? Well, I can tell you some of the reasons that I have now implemented Power Query in the cloud, because what it provides for you is the ability to refresh differently. So, and there's a couple things that you're going to want to think about when you're doing this. So let me flip over to this real quick, and I'll show you how to do a data flow so you can get an idea of how you can start doing that. All right, so one thing to remember is every time that you use that you're doing data flows, you're doing it within a workspace. So what I generally recommend if you're doing Power BI is to create some kind of a data set workspace, because of course you know that if you're doing a data model in Power BI, that your model and your reports are separate. 10, 20 different PBIX file, but your data model isn't in the same place as your reports. So when you're doing that, you can just create a new connection, call it a data flow, and just define a new table, and select your data from wherever you happen to have it. I've got mine in, and you can do any different kinds of files. I do Parquet. I've had a problem today with connecting to my Azure, so I'm going to show this with doing a OneDrive, but it's really not any different than if I did it in Azure. So I would use this as a data source. So I would put a data source in a data mart, so then I can have my data sources separate. So what's beautiful about that is that, like for example, my current client, they are using Salesforce, and they're using an on-prem system for the sources of the data that we're using. Well, everybody lights out of there at 5 o'clock, so I can start grabbing data at 6 from the on-prem stuff, because there isn't anybody using it. But the Salesforce people work in a different time zone, so I can't grab the stuff at the same time. So I can keep this separate from a data refresh perspective, because I can do that with a data flow. So this is just basically selecting it. I say next, and if you've seen the keynote, then this was going to make sense to you. I'm going to be doing Power Query in the Power BI service. This is going to be my data source. I will use this in my model as one of my data sources, and so that I can have them separate. So if I am doing all of my Power BI development, and I'm doing it in Power BI, that I do have some kind of a separation between my different elements. The only thing that I'm not 100% crazy about is that doing it this way really gets you outside of the whole CI/CD method, because there's no source control on this. But so you do have to be careful with who you let create your different data flows, because as you know, there's no built-in source control with Power Query. And this does assign it, so I'm going to call this Fire Data. So once I've got this particular source, I can refresh it when I want, and I can create a Power BI desktop, and then I can just basically connect to this as one of my data sources, put one of my tables, put this together in my model. So this is one way where if I'm just doing this, just saying get data, and then I can add that into my report. So want to get my data flows. Oh, come on. And then be able to grab my data. I'm too signed in. And I can just go ahead and grab this and load it into it. Come on. Come on. And the reason it's empty is because I didn't refresh it, which I should have done before I did this demo. But this is an idea of how to kind of get a model that is a little bit more modular than just standard in Power BI. So keep that in mind if this is how you're doing it. All right, so let's take a look at some of the other options that we could possibly do when we are looking at continuous integration. So the next one is going to be looking at Synapse. So Synapse is an ETL tool. So of course it's going to be something that you're going to be considering, or excuse me, integration, ADF, same thing again. This is an ETL tool. So naturally it's something that you're going to consider when you are doing your data transformation. And the connection tools make it stupid easy. A junior developer in a couple of days can go ahead and make a whole bunch of connections using data flows. Clicky, clicky, draggy, draggy. Isn't that the Microsoft way of things? And you can connect to anything you want, transform it, and spit out something on the other side. You can also choose to write a bunch of SQL. And when you do that, then it's not so buried in clicky, draggy, screen 42 that you drill down. And it does have full CI/CD support. You do have to read JSON, but it's not impossible to do, to figure out when you check something in, what happened. You got to do some JSON parsing, but it's possible to do. When you're doing it, I hope you don't do this, because this is an example of what you do not want to do when you are looking at getting data from and writing your ADF. This is all 100% data flow. And all it's doing, this looks like stupid complex, but it's basically taking data and making like 4 changes from one table to another. So it's moving it from one database to another database, it makes 4 changes to it. It looks all like this. So this is not very easy to read. And oh, by the way, if this crashes when it's halfway through, you have no recourse because nobody wrote it. So while this can work, wouldn't consider this an option that you should probably consider if you are using ADF. Because this is great, this works most of the time, but heaven help you if it doesn't. Because it's going to take you a while to figure out what went wrong and where. And what was wrong with it, where did you find this problem that it happened? Because everything's so darn buried. And there's nothing that anybody's written that allows me to back anything out. So that's going to be a custom thing every single time. Because this is committing as it's running. So what you don't want to write if you're writing ADF is stay away from data flows. Yes, they're easy, but they're expensive. And not just expensive because you have to debug them, but they cost money. And if you're looking at your Azure spend, you'll find out how much that they're costing you. You also can run into size limitations. I taught this really aggressive class on Synapse, and one of the labs that they had people do was try importing this like 3 terabyte file in that has an error in the middle of it. And people tried to do it with ADF, which is really mean because it timed out after 25 minutes, which is a giant waste of time, because it cannot do every single size of data. You can blow it up if you do large size. Like I said, you have to write rerunning. So write rerunning. What is going to happen if this crashes? Where are you doing any kind of interim write? So how are you handling, the acidity of this? And then complex data. I really feel sorry for you if somebody made you do XML data with ADF, because it's almost impossible to do. It's really, really hard. It does a lot of things well, that ain't it. So one thing that you can do, if you're doing this anyway, review your code. Because you need to have standards within your organization to make things easier to rerun, and troubleshoot. If nobody writes backout procedures or writes code that can be backed out, or one guy does and nobody else does, it's not helping you all out. Also, this gets into design patterns. Some of them are easier to find than others. Consistency is going to be your friend if you have to debug something that's wrong. So you need to develop standards within your organization and have people follow them and see how you can decrease complexity. And a lot of it basically is going to be writing more in SQL than you would do it in a data flow. So keep that in mind. If you are doing it this way, review each other's code. Review the old code that works. Because when that day happens that it doesn't, some fool, and that fool may be you, is going to be tasked with making it, rerunning it if it fails. All right, last one that I want to look at, totally new, is PySpark. So basically and I see more and more of this, where people are migrating and doing all of their ETL in Spark. Now, I get for a lot of people this is a pretty big ask, because you got to learn some new things that you're not familiar with. There's also, hey, let's face it, Stack Overflow exists, so we can all code. It's not as complex as you might think. There's many methods that allow you to parse complex data types. There's a regex library that's freaking awesome. If you ever use regex, you can use that on your ETL. Makes parsing XML being not that big of a deal. And you write it in notebooks. And hopefully, if people that you work with are kind, you include code and comments, because it's designed to have comments put within it with Markdown. So you're not just faced with giant block of code, I hope, that just has just the code in it. And you're not penalized for breaking things up and explaining things. So you don't have to do this like giant thing and not comment it. You can write things, in serial. So, and you can take a look at, the data that's run if you do samples, to see what's going on in there. So it's a lot easier to debug. So let's talk about this in terms of our goals for what makes the best kind of tool if we're doing data refresh. Okay, you can screw this code up too. The code can be very hard to follow. And not everybody who works in your organization can have the skills to write it or debug it. So, and there's so many different ways of doing this. If you look at different ETL code that people have written in PySpark, it's as unique as a person writing it. It can be all over the map. And then there's the thing about language. More and more people are standardizing on Python, but I walked into one client and they had a .NET guy who wrote all their code, and so of course he wrote it in .NET. Then he quit. So think about that when you are deciding. PySpark supports multiple languages. Scala, Python are the most popular. If you're using Synapse, you can use .NET. If you are using Databricks, you can use R. So even what language you write this in can all be different. Even if it is but it's all PySpark. Yeah, but you can write different languages in there too. And if you're mean, you can do that within the same notebook, which I have seen. So I will also say, if you are completely creating this in PySpark and not using any of the trigger functionality that's available, it's a little bit more tricky to write. And you have to write more stuff to do things like trigger emails. The logs are a little bit more challenging. You kind of have to dig for them. So think about that when you're looking to do that. So how can you mitigate some problems, because you're going to have problems with this one too, that you see with PySpark? Well, basically it's training, because now I do not see departments of people who know how to do this. And maybe there's one person who thinks it's cool, so they write it, which is, I've got a client like that now. So you need to figure out how you're going to make this not one person's job. People need to, I mean, you guys are here, so obviously you guys are into training. And your companies need to be into that particular mode. And I assume they all are, because most people have their company pay for it. And the other thing that you can do is kind of an interim step, is you don't have to go, knees deep into Python and do everything in Python all the time. I've got a client, and all that we're doing in Python and Spark is we are creating the data frames. And after that, I'm writing SQL, because it works, they understand it, and I hate maintenance, so I don't want to do maintenance. And so that can be kind of a stepping stone for doing your ETL, because you can write it in Spark, and you can write it in SQL, ANSI SQL. So, for those of us who are real familiar with Transact, you have to Stack Overflow that a little bit, because there's some things that are different. But you can write Python with SQL, and that makes that jump to doing all of your ETL not really that big of a deal if you know SQL. Also, it's a lot easier for many people to read SQL versus Python, just because of the way that the code reads. SQL is easier to understand. But if you're going to migrate to doing Python and Spark, well, make sure, pick a language first, for goodness sakes. Make sure that you've got some kind of standards. How are you going to bust this up? Because you can choose, again, you can write anything badly. If you write all of your Python in one giant code block and don't comment anything, and that one code block breaks and it's doing 10 different things, yeah, you're in the same bad place. So you want to make sure that you, are writing something that's designed to be rerun, that uses module development so that you're not doing everything all at once. You're busting up the process, so when something fails, you can more easy find where that happened. And you need to make sure that it's just not you that's doing it. It's everybody else, so that you're not stuck supporting bad code. So again, back to standards and review, which is really how anything is going to be successful at this. So let me take a look at showing you some PySpark with Synapse. And hopefully that has, my notebook is up here. Okay. Oops. Don't have the code up. All right, here's some example code, and basically what I've got here is and I wouldn't do it this way if this was real code, but just want to give you an idea. I'm loading a bunch of files that I have stored as Parquet. By the way, Parquet is compressed, so it's faster and easier to read, which is why people use Parquet all the time. And I'm loading up a bunch of different files, and then what I'm doing here is I'm just taking a look at what I loaded up by just displaying 10 rows of it. No big deal. And I'm loading all of these up, and I'm going to use this command, here, that will allow me to write this stuff in SQL. And this is really I'm going to blow this up a little bit so you can see it better. But this is really what you're going to, it screwed up the paint on this. But if you have this thing that says DF account, that's a data frame. And that's where I've loaded my file into memory. And then if I use the command create or replace temp view, then it is at this point, it considers it a table. And if it considers it a table, then I can start writing SQL. And I don't know why. Here we go. So I can just write a select statement, because I've said, hey, that's a table now. So I'm just selecting a bunch of tables, probably doing some renames here, maybe doing some joins at the end with all of the tables that I have, because I said, no, it's not a table because I did this create or replace temp view. So now it just acts just as a simple select statement where I can do whatever I want to with it. So this is basically allowing me to write Python and SQL, and then I can go ahead and write that to a data lake at the end. So then I can write, here's some pretty intense SQL, and then basically I'm going to say, oh, that looks good, and then I'm going to go ahead and write it. So this is me writing the SQL that I just wrote. So I'm just going to overwrite what I have there into another file. So let's get into a bit of I know I don't have that much time, so I need to get a bit, oops, idiot. Need to get into my design patterns here to show you if you're going to do this, what kind of ways that you should do to make this work. All right, so I tend to combine everything together. The connection tool in ADF works great. I don't want to write that Salesforce connection thing all by myself. Goodness gracious, what a pain in the neck that is. So I'm going to use both of them. So I'm going to use whichever tool does a job faster and saves me time and is easy to read. So I connect using the connection in ADF. After that, I write it to a raw area. I take my notebooks that I write to transform my data, and I put them in an ADF pipeline. Why? Because I really like the trigger mechanisms that are already there. Yeah, I can write all those. Why should I? It's also got really good logs so that I can find what's wrong pretty easily if I use that kind of pipeline. So I tend to stick with doing that. I use data frames because they're more efficient, and I will do this in Synapse, and when I'm done, I'm going to write to a flat file, and I'm going to create a serverless database on top of that. That way, if somebody wants to do ad hoc querying, go to town. It's also pretty easy to have Power BI users connect to it, because from their perspective, they think it's a database. And it's cheaper. This won't work with really large data sets. With really large data sets, you will have to actually create a data warehouse to support ad hoc querying. But what I would do first is I would try serverless, because it's free, relatively speaking. It's $5 for a terabyte, before I put up something that costs me $5 a minute. So give it a shot. Try to do a serverless database to support ad hoc querying. And if someone says, yeah, that's just too slow, then explore your options, because that's easy to do. So what I'm going to do is I'm going to move my data through these different areas. I'm going to write my source data into raw. And then I'm going to put it into structured. And I may or may not stage it. That depends on the data, how messed up it is. I'm probably going to have some data into reference, things that maybe doesn't exist in one single source. Things like location might be something that I have as reference. Like, I have a company, and believe it or not, they never thought they needed to put in their own addresses. So somebody put together a spreadsheet, and that's in reference. Might put a date table there, too. I tend to write those in code, but if there's some rules about holiday schedules that I need to find out, I might have that in reference. I'm going to put things that I'm going to make my database, my data warehouse, I'm going to put that in my curated area. And it's going to look just like a data warehouse. It's going to have facts, it's going to have dimensions. Of course, they're going to be folders and Parquet format. And this is how I'm going to write them. My raw is pretty much going to be, just straight up integration. I'm just going to copy it over, no big deal. Structured, I'm going to be doing my all of that in Spark. Stage, I'm going to be doing that in Spark too. I'm going to be using Spark to modify my data frames and put that into code that I can use. Reference, it depends. If I'm only uploading a file like once or twice a year, I might just throw that up there just using Data Explorer. I mean, why not? If it's not a big deal, I'll just throw it up there. Depends on the effort that's required. For curated, I'm going to write Spark for this, so I'm going to create my area that is going to have my data warehouse in it. I'm going to use Spark code to do that. And I'm going to build in an archive. And I'm probably going to integrate that off, periodically move that to cold storage. If you're doing analytic analysis, nobody really cares about data that's greater than 2 years old. Because seriously, who thinks that data collected before COVID is going to have a significant impact on the trends going on now? Well, it's like a different century. So you don't need that for most kinds of data warehouses because it's just not relevant anymore. So you can choose to keep that in the same place, or you can just move it off in a date basis. And that's pretty simple thing to do on integration. And because it's quick and dirty, I tend to do it that way. So these are the kinds of rules that I look at when I'm looking to do this. Now, with these combination issues, you need to make sure that your code can be rerun. So yes, again, don't write bad code. Write stuff that you know is going to break. And you're like, well, why is it going to break? Because someone's going to give you bad data. It just happens. I mean, you may think to yourself, no, that's never going to happen, and it will. So make sure that you've got code that can be rerun. Make sure that you're handling complex ETL in a way that somebody can actually go in and support it. Make it modular. Comment the thing, for goodness sakes. And provide training so that it's not just one person's job. Because if it's one person's job, it'll make great sense to them. And maybe the rest of you, maybe it will, maybe it won't. And they don't care. So make sure that more than one person knows and that you're providing training so you can get better at writing all this stuff in Python. So in short, what's the best way of doing it? Use the best tool for the job. So use ADF where it makes sense, primarily to copy data from complex sources. If you are doing Databricks, there's no reason you can't put that in your pipelines. I like having like the one pipeline because I just like the way that if I have to debug something, if I need to trigger something, the way the ADF pipelines works makes that very easy to use. And you want to make sure that when you're developing them, that you're developing something that can be supported and something that's easy for you to monitor because you don't want to have to go to 10 different places to look at stuff. Which is why it's much easier if you're doing this within Synapse because you've got one place to look for all of your different kinds of logging. So think about that when you are selecting which one is the best one. So in summary, we looked at the design goals, looking at what you were trying to do. We want to make sure that we do continuous integration whenever we can. If we're not, we're using Power BI. What the best ways of doing that, looking at using data flows, making sure if you're doing it in ADF, because that's a tool that you've got, make sure that you're not writing a whole bunch of code that people can't understand and support. We looked at the different kinds of tools that we can use, and I showed you some examples of how you could possibly write things that make it easier. Reviewed no matter which way you're doing it, you can probably figure out a way to do it better if you look at how it's presently performing and then develop standards around it. Look at doing CI/CD integration with different development tools. And then, most importantly, make sure that it's not one person doing it and that you're consistent in how you do your ETL so that it's easier to debug. And with that, any questions?
I suppose one challenge that I find is that there's so many different components and aspects, as you've discussed today, that you can fit into things, and it's sort of, and I suppose it also depends on very much, you could use something like we've had a situation where you could use Databricks, or you could use SQL Server to do the same thing, but how are they resourced? Are they resourced sufficiently to be able to actually compete against each other?
Well, this also gets into what your Azure spend budget is. I mean, because if you, like, for example, if you want to go all in on Power BI, you better be spending the $5,000 a month to do it because you need those premium features. If you're doing a lot of stuff in ADF, if you write it in SQL, then it's relatively inexpensive to run. So it's not all, and what you need to do is figure out, consistency and then analyzing what the most important elements are too. Because if I wrote the whole thing in Spark, so thinking about that, I had a client that said, well, I wrote my own thing because I couldn't figure out how to make that tool, I spent 3 days writing a connection because I didn't want to use the ADF one. Well, that's not a great use of anybody's resources because I can connect to Salesforce in 5 minutes and you spent 3 days writing something because you didn't want to use it. Do the math on that. That doesn't make any sense either. So, and yes, there are a lot of ways of doing it. Somebody else had a question? Yeah.
Sorry. Quite small amounts of data. Oh, sorry. If you're talking quite small amounts of data, like less than 50 gigabytes and that kind of stuff in your database or whatever, would you ever consider using Synapse, or would you?
Yeah. The question, if I had 50 gigabytes, would I use Synapse? Yes, because I want to develop a way that if it crashes, then I can figure out what went wrong and fix it. And so that's why I would use Synapse, because it's relatively easy to do. And the code's not that hard to write either.
I'm talking compared to like a serverless SQL server and Data Factory.
So if we're talking data transformation versus using it, first, if I would transform the data within Synapse using Spark whenever I can, because it's easier to support over time. So the size part, yeah, it's helpful when it's more efficient when it's bigger, but it's not like it's inefficient because it's small. So, and yeah, I use serverless unless somebody says we got a terabyte. Then I'm like, well, okay. But most people think they need, like, I had a client that they're defense contractors, they had stupid money, and they said that they said that their Azure budget we said, well, we think your Azure budget every month is going to be $40,000. And they said, oh, that's okay. I generally don't have clients like that, though. Most people don't want to spend that kind of money when they don't have to. So always mind the resources. I don't think you ever go wrong with that. Any other questions? Any more? All right, well, thank you very much. Appreciate you staying.